This is linear algebra. We want to talk about linear transformation. Previous video, we talking about definition of transformation and matrix transformation. I want to talk about definition of linear transformation. Linear transformation have two conditions. First, addition of two matrix is gonna be preserved under the transformation. So addition of two matrix, go to the transformation, each image and first and add later, okay? Scalar multiplication times vector, go to the translation, transformation, you're gonna go to image of the vector u times scalar multiplication. So simply linear transformation preserve operation of addition and scalar multiplication, okay? So when we talk about metric transformation previous videos, right? So every time you're gonna have t value, that's you say Rn, go to the Rm, you're gonna define x metric, go to the tx by the metric. So metric transformation is always linear. How do you know that? Guys, we talk about this one is u vector plus v vector. That's the metric and vector. Product of metric and vector, that's going to be exactly this form. So which meaning is this one is transformation u plus v vector exactly tu plus tv. Okay, so metric, first condition, second condition, scalar multiplication. A metric time go to the C vector. Then this scalar gonna be outside A metric and B vector U, right? This one is transformation notation, right? The TCU vector, that's gonna be CTU vector. So we confidently say every matrix transformation is linear transformation. So another property of linear transformation, all zero vector go to the zero vector. So how do you know that? Let's solve it, guys. How do you know that? Okay. So t, any vector times zero is zero. Guys, this is always zero, right? So this one is scalar multiplication is coming out. Zero times transformation. So this is a vector, this is a zero. So this one gonna be zero vector. Okay, guys? Zero times any vector always zero, guys. Second is gonna be this one, t cu vector plus dv vector. So linear transformation, you separate addition. Cu vector t dv vector. Then scalar multiplication, this number is coming out of this transformation. So C tu plus d tv. Okay, every time when transformation is linear, they preserve this property, guys. All right. Let's do the practice problem, guys. So if you want to try by yourself, pause the video, you can try this practice problem. So T gonna be transformation. We're gonna define this A metric right there. That's the A. Here is X. This one is A, X, okay? So when you do the product of metric and vector, you're gonna have negative X2, X1. So anytime you put the number here, so this one is a 4 and 1. Where is this vector R2? Where is this vector R2? Okay, so add two vector, that's each component in each entry. 4 plus 2 is a 6. 1 plus 3 is a 4. So we want to find image of each vector right there, okay? So what kind of a transformation they did under this metric transformation? Let's just start with TU first. What is TU? So x go to x1, x2 go to negative x to x1, right? So we have this one go to what? U vector is 4 and 1, so negative 1 and 4. Guys, make sense? TV gonna be what happened this one? X1, X2, this one is negative 3 and 2. How about this one? T, U plus V, 6, 4. That's going to negative 4 and 6. Can you see that? This linear, here it is, guys. Tu plus tv is what happened, guys? This one, negative 4 and 6. Exactly these two vector is the same. Okay, let's just sketch this each point. U vector, V vector, U plus V vector. Okay, let's go for 1. What is a 4, 1, guys? 4, 1 is a 4 and 1. That's the U vector, right? This is U vector. What is V vector? 2, 3 is right there. That's the V vector. Add together parallelogram rules. This one gonna be U plus V vector. Okay, everybody make sense? Now, after transformation, what happened, guys? What happened? So Tu gonna be negative 1 and 4. Negative 1 and 4. That's gonna be Tu. TV gonna be negative 3 and 2. That's the TV. Right? So how can find Tu plus V parallelogram? Let's just get the parallelogram. Parallel, this one is right here. Right? So you have Tu vector plus V vector gonna be. So this one is right there. Tu plus V vector. Okay? So what happened this transformation? Can you see that, guys? Here. U vector is 4, 1. So simply 4, 1 go to negative 1 and 4. 2, 3 go to negative 3, 2. Can you notice something from the algebra class? This one is translation, rotate by 90 degrees. That's represent this transformation, guys.